Woohoo! We are live. This is Math 60, Intermediate Algebra 2.2, and we are talking about graphing lines and graphing linear equations. And the next topic we want to talk about is intercept. Now, intercept is an old word. It basically is going to mean to intersect in a way. But this is intercept instead of intersect with a CT. This is a PT. So intercepts are the points where the graph of an equation intercepts, so runs into one of the axes. So I'm going to freehand a couple of axes. I'm going to say, let's pretend these are, well, those are relatively straight. An x-intercept is when y equals 0. So that would be like a point here. This is the x-intercept, which we frequently write as x-int with a little hyphen in between. So the x-intercept sits on the x-axis, and because of that, it's not up and it's not down. So the y value is 0. The y-intercept is when x equals 0. And that would be an example, would be something like this. And this means if it's on the y-axis, it's not to the left and it's not to the right. So in other words, the x value is 0. So notice that these are reversed. If we want the x-intercept, y is 0. If we want the y-intercept, x is 0. So it's kind of, they're crossways. There we go, crossways. Yes, I'm not going to be a YouTube star anytime soon. There we go. Okay, so first thing we want to do, let's just find the intercepts for the graphs of these equations. So if I get the equation 3x plus 2y equals 4, I want to find the intercepts. So I pick one of them. Since it's listed first, I'm going to go ahead and start with the x-intercept. So in other words, y equals 0. So what I have to do is I take my equation 3x plus 2y equals 4, except I'm going to plug in y equals 0. So 3x plus 2 times 0 equals 4. So in other words, 3x, this goes 0, equals 4. And then I can divide both of these by 3. 3x over 3. Get my handy dandy red pen. The 3's cancel, and I get x equals 4/3. Oh my goodness, I completely underestimated how much space I was going to need for this. So I am going, what am I going to do? Oh, I know what I'm going to do. Ooh, can I do that? No, someone has taken my tools. I'm going to go ahead and erase that. We will do that one on the next page. So when y equals 0, we plug in 0, x equals 4/3. So we've got the coordinates 4/3, comma 0. That whole thing is the x-intercept. Ooh, everything's so wiggly today. Okay, so let's look for the y-intercept. When you see the copy of this, when you see the notes, this is going to be beautifully whited out like magic. The y-intercept is what happens when x equals 0. So we take 3x plus 2y equals 4, or 3 times 0 plus 2y equals 4. In other words, 2y equals 4. Divide both sides by 2, and I get y equals 2. And that's the y-intercept, is what happens when x equals 0. So I've got 0, and then y equals 2. And this is the y-intercept. So far, so good. I took a lot of space doing it. But, you know, if it makes more sense, use lots of space. So now what about that other one, which I crossed out, but I think I can remember it. I think it's B. It is the equation x equals 4. Now, the first thing you're going to notice about this is you're going to say, wait a minute. These are supposed to be equations in 2 variables. right? There's an X, there's a Y. Where's the Y? And the answer is, I don't know. On vacation. Slept in, didn't make it to the equation on time. I don't know what happened. Let's take a look and see if we can figure out what happens. Now, I don't know what to do here because I can't just plug in a 0, because if I try to put a 0 in for X, I'm going to get 0 equals 4. That's not true. 0 does not equal 4. So this is very confusing. So what I'm going to do is I'm going to set up a table of values. And I'm going to notice, it says X equals 4. That's all the information I'm given. So can X equal 0? Nope. X equals 4. Okay, I better start with X equals 4. Now, does it tell me anything about Y? No. That means Y has total freedom. Okay, so could Y be 1? Sure. Okay, let's try another value. Well, I have to go with 4. What's another value for Y? 2. You got it. 4. Could it be 0? Is there anything that says Y can't be 0? No. So I could do 0. Let me, and I didn't write out a graph for myself, so I'm going to have to do a very sketchy graph. I'm trying to set a good example by using my ruler. It's a bad habit of mine to freehand this a lot. The more you use your ruler, the better the graphs will look. In general, I encourage you to use good paper whenever possible. Okay, 1, 2, 3, 4. Try to be as close to equally spaced as possible. It's not perfect. My 1 is kind of big compared to my others, but it's close enough. And I've got a couple of points here for Y. So I've got the point 4, 1, 4, 1, 4, 2, 4, 2, 4, 0, 4, 0. Those 3 points line up, stack up right on top of 4, like this. Helpful hint. If when you go careening through numbers, you don't just cross over them, you give them a little gap like that, you look so professional. People will be like, oh, wow, where'd you learn to do that? And you'll be like, oh, City College, best college ever. And everyone's like, I know, I've heard of it. Okay, so let's take a look at what's going on here. This line crosses the x-axis. So this is an x-intercept. It's at 4, 0. That's where Y equals 0. Is there a Y-intercept? And the answer is no. This runs parallel to the Y-axis. It never crosses. They're going to go, they're like best friends. This is like a road movie or something. These are like beat poets. They're side by side their whole lives. Ooh, look at that. So only an x-intercept, no y-intercept. So sometimes you're going to get weird answers. Most of the time, however, you can just plug in y equals 0 or x equals 0 and get your intercepts. Okay, so that's the building block we're going to have here. Now, what I would like to do is to graph, because we're not done yet. You know me too well to think we're done. It's only a 9-minute video. Oh my gosh, we're just getting started. Get yourself something, good to snack on and something nice to drink, and let's settle in. Let's do some math. So I would like you to graph the equation 2x minus 3y equals 12 by finding the intercepts. So first, let's check. Does this follow the rule of a linear equation in 2 variables? Got my 2 variables. Woo! Got my linearity. I don't know if that's a word, but basically x is just x and y is just y. No x's or y's doing anything weird, multiplying times each other, squaring, square rooting, denominatoring, none of that. These are good, calm little variables. Oh, thank goodness. So what does it mean to graph by finding the intercepts? Well, here's the thing. Remember when we talked about a line? If we know the graph is going to be a line, we only need 2 points. What if we use the two intercepts as our 2 points? So what does that mean? Well, let's start with, I like to start with x equals 0. You know, that's just me. So I'm going to start with x equals 0. If you want to start with y equals 0, that's fine. So remember, this is going to be the y-intercept. So 2 times 0 minus 3y equals 12, which tells me 2 times 0 is 0. So negative 3y equals 12. I'm going to divide. Now this one is sneaky. I don't know if you guys all caught that. It's negative 3 times y. You divide, you don't add. Because between the 3 and the y is the multiplication. That's what you got to undo. So a little sneaky there. We'll cancel the negative 3's over here. And we get y equals 12 over negative 3. 12 over positive 3 is 4. So 12 over negative 3 is negative 4. Okay, so we've got the point 0, negative 4. Okay, I'm going to look at when y equals 0. That's the x-intercept. 2x minus 3 times 0 equals 12. Okay, that means 2x equals 12. Well, this one, that's almost easy enough that I could just shout out what the answer is, right? I'm going to divide both sides by 2. And I'm going to get x equals 6. Cancel, 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 cancel. So my coordinates, or my ordered pair, is 6. Remember, 0. Y is 0 there. I've got my x-intercept. I've got my y-intercept. Okay. They are, I need to be able to go up to positive 6. I need to go to the right to positive 6. I need to go down to negative 4. That should not be a problem. So I'm going to draw my graph. And again, you can put this right in the middle if you'd like. Graphs don't always have to go right in the middle. I'm just going to give myself enough room because 6, 0 means I have to get out to 6. 3, 4, 5, 6. Now, pardon me, earlier in the video that I just made, I believe, we talked about, or I mentioned, scale. And I said it is possible to just draw one number and satisfy me. So this is enough. Putting this dot here telling me this is where x equals 6, I'm happy. I'm thrilled. I'm like, yeah, it is. That's totally what it is. Some instructors might want you to give more values. I'm perfectly happy with that. Label your y-axis, and then I'm going to go down 1, 2, 3, 4. There's my negative 4. There we go. We've got 2 points. Connect the dots. It's that easy. So you're going to ask me, seriously, it's that easy after you did all of the points before? And the answer is yes, it is that easy. Now, what are the downsides? Well, if you only find 2 points, then each point is incredibly important. So if you make even a little mistake, your line will be completely wrong. Like, what if I accidentally forgot the minus here? I got 12 over 3 is positive 4. Well, that would have put the point up here, and the line would have looked like this. Completely wrong, right? So what some people do is they do another point in the middle, or another point somewhere else. So for example, what would that look like? Well, what if I check, it's called a checkpoint. I'm going to pick the point that's right in the middle between x equals 0 and x equals 6. I'm going to go with x equals 3. It might work, it might not. Sometimes you'll try points, you'll be like, and you'll end up with fractions. I'm kind of hopeful that's going to be negative 2. Do you see that? If this is x equals 3 and this is y equals negative 2, I'm hoping that's an actual point. So that's my checkpoint. So let me try x equals 3. I get 2 times 3 minus 3y equals 12. So that's 6 minus 3y equals 12. Okay, subtract 6, subtract 6. I ran out of room. I get over here, I get just the negative 3y. Over on the right-hand side, 12 minus 6 is 6. Divide. Y equals negative 2. So I've got the point 3, negative 2. There you go. My checkpoint lies on the line that I already drew. So it's a way to check your line. Are you required to do the checkpoint? No, this is optional. Just depends on how certain you want to be. Like if you're taking a test, doing another point just to double check your work, it's worth it. It only took, right? It took me 2 or 3 minutes. On a test when you're under pressure, maybe it takes you up to 5 minutes, but still that way you're like, there, my graph is correct. Okay, so I wanted to offer up, could I say, well, heck, what's another way we could have graphed this line? So if we have 2x minus 3y equals 12, and instead of finding the intercepts, what's the other way to graph it? Well, there are a couple of other ways. We're going to learn some more in the rest of the chapter. I'm just not going to be able to be that straight today. Sorry. In the rest of the chapter, we're going to learn a bunch of other techniques, but the one that we already know is a table of values. So yeah, I think that lines just are eluding me today. So what does that mean? Well, I try various things. I would start with x equals 0. And we already know without doing the work, I would have gotten negative 4. And then I would try x equals 1. Okay, this is going to be kind of messy. 2 times 1 minus 3y equals 12. 2 minus 3y equals 12. Subtract the 2, negative 3y equals 10. Y equals negative 10 thirds. That's disappointing, but okay. So I've got the point 0, negative 4. I've got the point 1, negative 10 thirds. What happens when x equals 2? 2 times 2 minus 3y equals 12. Okay, 4 minus 3y equals 12. Subtract 4, subtract 4. Negative 3y equals 8. Y equals negative 8 thirds. So this gives us 2 negative 8 thirds. Okay, so y is finding the intercepts so much faster and cleaner because these are the 2 important points. When you do a table of values, if you just try different values of x, there's no guarantee they're going to give you nice values or important values. So you can use a table of values. And in fact, let me show you where these points are. 0, negative 4 is right there. Let's see. There we go. Working with mirrors is not my favorite thing. There we go. So 0, negative 4 is right there. Where the heck is 1, negative 10 thirds? Well, so if we go to x equals 1, negative 10 thirds is a little bit more than negative 3. So that's that point right there. It's right there. And then what happens when x equals 2? That's this point. And that's going to be here. Negative 8 thirds is negative, just around negative 2 2/3. There we go. It's exactly that. So it's right there. So what we're doing is we're just coming up with these points again. And we could, if we did a table of values that extended long enough, we would find all of these points and be able to graph the same graph. So 2 different ways to approach it. Woohoo. I personally think intercepts is the way to go, but you can always fall back on the table of values. And then one more thing. I know this video is getting a little bit long, But one more thing, because I want to make sure, we talked about this a little bit before, but I want to really make sure you understand the difference. Graph y equals 5 and x equals 5 on the same set of axes. Now, these are weird graphs. Already, you know they're weird because each of them only has one variable. So that's already going to be weird. So this is a linear equation in one variable, each of them is. These are going to be really useful in the future. Right now, we're just going to graph them and forget them. But when you go on in math, we're going to use these as fences for other graphs. Some graphs are kind of rambunctious, and so we're going to have to put them in fences to keep them from going totally bonkers. So these are going to be how we draw the fences. And what's really important for now is that you practice doing this and you're able to figure out what they look like fairly quickly. So y equals 5 is the boring answer problem in my mind. Okay, I'm going to try. When x equals 0, can x equal 0? Sure, we don't know anything about x, so we can make it 0. What's y? This is a trick question. It's 5. Okay, when x is 1, what's y? Well, it's 5. Okay. What's when x is 2? What's y? It's 5. Notice y equals 5. No matter what happens to x, y is 5. If we come over here and we look at the table of values for this one, wait a minute, x equals 5. So that means we have to start with 5, but then y could be 0. We could start with 5, y could be 1. We could start with 5, y could be 2. X has to equal 5, but y has total freedom. Y could be anything. And really, these numbers could be anything. Same thing over here. You could pick anything. If you wanted, this could be like 200 million and 6, if you wanted. Now, that's going to be really hard to graph. Or you could pick when x equals pi, what's y? Well, y is 5. So you can pick funny numbers, but then you're going to have to graph them. Okay, so for this one, because I have to get all the way to x equals 5 and y equals 5, I'm going to move my axis. My y-axis is going to move over to the left a little bit, and my x-axis is going to go down a little bit. What is the effect of doing this? Well, if I graph like this with my axes kind of pushed over to the left and down, it means I give myself lots of room in the first quadrant. These are all positive numbers. So here's x, here's y. 1, 2, 3, 4, 5. There's 5 in the y direction. 1, 2, 3, 4, 5. Here's 5 in the x direction. If you guys were here, you could tell me what color you want. For y equals 5, I'm going to draw that with the green. And for x equals 5, because we're getting into fall and Halloween, so I'm thinking pumpkins. So we're going to do orange for x equals 5. Okay, so for y equals 5, I've got the point 0, 5, 1, 5, 2, 5, and then that weird pi. Pi is just over 3, 5, so kind of like right there. So we can see y equals 5 is going to be a horizontal line. Woohoo! Horizontal line. It's y equals 5. So notice that if it had been y equals 4, it would just be down 1. Y equals 3, y equals 2, y equals 1. Interestingly, y equals 0 is the x-axis. Y equals 0 is the x-axis. Okay, let's look at the orange graph. So this, I should say, horizontal. Wow. There we go. And then let's look at this graph, x equals 5. So x equals 5, y equals 0. X equals 5, y equals 1. X equals 5, y equals 2. X equals 5, y equals 200 million and 6 is way up there. I won't take the time to graph it. We can already see the pattern here. I know, look at that. I can open up highlighters with one hand. I know this is my superpower right there, my talent. This is the equation x equals 5. This is a vertical. Notice it's vertical and not vertical. I know there are a lot of ways to spell English words. This is an ow one. Vertical. This is horizontal. Notice if it were x equals 4, it would be here. 3, x equals 2, x equals 1, x equals 0 is the y-axis. X equals 0 is the y-axis. Y equals 0 is the x-axis. X equals 0 is the y-axis. Now, what does this all mean? Well, for this class, you need to be able to graph them. But in a perfect world, you would memorize them. You would just remember, if it's y equals 5, it's going to be horizontal. It looks like this. If it's x equals 5 or something similar, it's vertical. It looks like this. That will set you up the best for your next math class. Okay, I'm going to end at 25:55 if I can. Oh, I already missed it. Shoot. Okay, well, math on, guys. Math on. Woohoo.